Hi kids, and welcome back. We're going to jump right into our discussion of pure liquids to help provide a better foundation for our heart of our discussion, which is solutions. Now, we talked earlier about intermolecular forces in liquids and the strength of intermolecular forces in liquids, and these two properties here are the result of those intermolecular forces. The first concept we want to talk about is cohesion. It's really one word, but I wanted to emphasize that in terms of being together. Cohesion. And this is the attraction that molecules have for one another. So to stay kind of pure. So, it's kind of like your group, your little peer group at school. You have these cohesive forces of attraction, and they're between things that are alike. You're in your group because you have similarities. So that would be a cohesive force of attraction. Now, liquids that have strong intermolecular forces will have strong cohesion. They'll want to hold together. Like in this case, it's hard to see, but that's a penny. And I'd like you to estimate how many drops of water you could put on the surface of a penny. And then you're going to remind me to have us do that in class. And it's a surprising number of drops of water will fit on a penny due to the strong hydrogen bonding or intermolecular force between water molecules, because water is very strongly polar. Now, cohesion adds to what's called a high surface tension. And it's really about the surface molecules. If the molecules down here can feel attractions in all different directions, but molecules on the surface have this stronger attraction because they're not maximizing all of their attractive forces. So there's a tendency to want to pull in to maximize forces. And here it's just showing an insect walking on water. The surface tension of water is very, very high. You have to break those attractive forces to break through the surface of the water. I think it's a pretty good analogy, but any of you who've done a belly flop on the surface of water knows that can be pretty hard, breaking that surface tension. Now, the other force of attraction is adhesion. Again, it's one word, but I want to emphasize this. Ad as the prefix there. Add means to another, to something else, and this is the attraction of a liquid to another surface. So let's say you are going out you're hanging with your friends, and you have a strong cohesive force, and then a really hot guy shows up. And you start to feel an attraction. Sorry, guys, I left you out of this one, but just pretend for now you're the hot guy, right? Okay, so you might sense an attractive force here. That would be an adhesive. Whoops, I didn't mean to do that. That would be an adhesive force of attraction here, okay? And we can compare which is stronger and which is weaker. So cohesive is together between like molecules, and adhesion, wow, that really bothers me that Mimeo does that. I have to talk to them about this. Adhesion is between two different substances. Okay, now we've seen this when you measure with a graduated cylinder. We have water, and remember, water makes a meniscus. And remember, we always measure for consistency's sake. We always measure at the bottom of this meniscus. Well, the meniscus forms due to capillary action. Okay, and what that is what it occurs when the adhesive forces become greater than the cohesive forces. So the water's attracted to the glass, that silicon dioxide in the glass, and the water starts creeping up and being attracted to the glass and starts breaking some of the attractions to itself. And so it'll draw the water apart from one another, really. So if you were more attracted to the guy than you were your friends, you're going to pull a little apart from your friends. Not completely, you don't want to break friendships, but you'll pull a little bit away as you spend more time or seek to strengthen that bond. Now, this would be mercury. Mercury's, so let's refresh that. In this case with glass, the adhesion of water is greater than the cohesion. In the case of mercury, its adhesive to the glass is less than the cohesive properties. So do you see here how mercury's resisting going towards the water? It's really kind of hunkering down internally and trying to pull internally. And so that you're not going to have the same type of meniscus. Had it been mercury, you would measure at the top of that meniscus here. Okay, so this is capillary action. Examples of capillary action is water being absorbed up the root of a plant. Or if you've ever done any blood tests and blood typing tests, remember when you take a glass tubing and you put it on top of that drop of blood, and when you do, that blood rises very quickly up the capillary tube. Okay, that's because of the capillary action or the adhesive properties of the blood to the glass of the capillary tube. So that gives you a couple of the other properties. We want to talk next about the vaporization and phase changes of liquids. So until then, you got it. This is signing off.